Hello and welcome to problem session 3 of this introduction to calculus with Wolfram U. The topic for this session is special derivatives. And what we'll do is to take up several examples to review the rules for derivatives and also get some additional practice on this topic. So let's begin with problem number 1, which says compute the derivative of 7x cubed minus 2. Now that is a polynomial, so things are quite simple. So what you do is you apply the power rule to 7x cubed, and the answer is 21x squared, and that's a constant, negative 2, so derivative is 0, and you can confirm the answer with d and check that it's actually 21x squared. So here is a plot of the function and the derivative. The blue plot is the function and the orange plot is the derivative, and you can see that the function is increasing, so the derivative stays non-negative all the time. Problem number 2, which says compute the derivative of sine of x over x squared. Now this requires a quotient rule, so what you do is you do denominator times derivative of numerator minus numerator times derivative of denominator over denominator square. And when you do that, you get x times cosine x minus 2 sine x over x cubed. And you can check the answer with d, and you get back almost the same thing, except that you might need to take an LCM to get both of them to agree exactly. So here is a plot of the function and its derivative. So let's go on to number 3. So it says find the derivative of x times secant x minus 2x squared. So now for the first term over here, x times secant x, what you do is you work out the derivative with the product rule. So you get x times derivative of secant x plus secant x times x prime, and that's the answer over here. You can check the answer with d. And then for the 2x squared, the derivative is 4x by the power rule. Then you combine them with the difference rule, and you get the answer, and you can confirm that d to check that it's correct. And finally, here is the plot of the function and its derivative. So on to number 4, which says compute the derivative of square root of cosecant x. So here you apply the chain rule, which says that you have the derivative being 1/2 times cosecant x raised to negative 1/2 times the derivative of cosecant x. So you do a bit of work and you get back negative 1/2 cotangent x times the square root of cosecant x. And you can check the answer with d, and you get back almost the same thing, except that d has simplified a bit more and replaced the cotangent over here by cosine over sine. And you can then plot the derivative and the function and get this nice visual for the whole problem. Okay, on to number 5, which says find the derivative of 4 times the cube root of 6 minus sine 5x. So this is a composition, so you need to be a bit careful. So what you do is you do constant 4 times 1/3 into 6 minus sine 5x to the negative 2/3. That's 1 minus 1/3 raised to minus 1. And then you get the derivative over here of 6 minus sine 5x, which is negative 5 cosine 5x. So that's the final answer over here. You can check it with d, and you get back the same result. And then you can plot the function derivative and get back a plot for the whole problem. Okay, on to number 6, which says find the second derivative. So this time it's the second derivative of this quotient. So it's a quotient 2x plus 3 over 8x minus 1. So you apply the quotient rule. So it's again denominator times derivative of numerator minus numerator times derivative of denominator, and you get back a result. And you can check the answer with d for the first derivative. Then apply the power rule to the answer and you get back the second derivative, and you can confirm the answer with D and check that you get the same result. So here's a plot of the function and its derivative. Let's go on to number 7, which says find the second derivative of this product. So you apply the product rule, first function times derivative of second plus second function times derivative of first. You get the answer D to check. Then you need to apply two rules, the product rule over here for each of these parts separately, and then the sum rule, and after you do some work, you get the answer over here by hand. You can confirm with D and check that the answer is correct. And then finally, we plot the function and derivative. But notice we are talking about the second derivative over here, and it turns out that in this case, the second derivative is all non-negative. Okay, so let's go on now to problem number 8, which says find the third derivative of sine of x squared. So you apply the chain rule to get the first derivative. That's going to be cosine of x squared times 2x. That's from the x squared over here. Check the answer with D. Apply the chain rule and the product rule over here. So you get 2x times the derivative of the second factor, etc. And check the answer with D. And then finally you can apply three rules, the chain rule, the product rule, and the difference rule to find the third derivative and confirm the answer with D. So here's a plot of the function and the third derivative. On to problem number 9, which says find the third derivative of 4x cubed minus 1 over x. So for the first derivative, you can apply the power rule and the difference rule. So you get 12x squared from the 4x cubed and 1 over x squared from the negative 1 over x. Check the answer. Apply the same rule again. So you get 24x minus 2 over x cubed. Check the answer with D. Then find the third derivative, which will be 24 from here and a plus 6 over x raised to 4 from there. And you get back the same result from D. And finally, you plot the function and the third derivative. Okay, on to problem number 10. Now, this is about the topic of implicit differentiation. So keep in mind that the derivative of y is going to be y prime. So the equation is y times cotangent of x equal to cosine of y, and you want to find the derivative at pi over 2 comma pi over 2. So x and y are both pi over 2. So when you apply the rule, you get y times the derivative of cotangent, which is negative cosecant square x, plus cotangent of x times y prime. And on the right hand side, you get negative sine y times y prime. Check the answer with D. Then you solve for y prime x, like I've done over here. And finally, you plug in the value of x and y, and you get back pi over 2 as the derivative at that point. Once you have the derivative, you can compute the tangent line, y equal to pi over 2 plus pi over 2 times x minus pi over 2, and plot the curve and the derivative, and you get back this beautiful plot over here. On to number 11, which says compute the derivative for this implicit function. You have y squared over there, so you get 2y times y prime equal to 6x minus 1 for derivative. Check that with D. Solve for y prime. get back the answer, plug in the values, 1/2 and 1/2 for x and y, and you get back 2 as the slope or the derivative, and you plot the tangent line like I've done over here, and you get back the curve and the tangent line at the given point. Okay, on to number 12, which says find the normal line to this curve at 1, 1. So the normal line is perpendicular to the tangent line, so you must first find the slope of the tangent and then work out the slope of the normal. So if you find derivative over here, you get 8x plus 4y plus 4xy prime. That's from this middle term over here, plus 2y times y prime equal to 0. Check with D. Solve for y prime. And you notice that you get back just -2. And we'll see why that's the case in a minute. So the slope of the normal line will of course be 1/2 because it is perpendicular to the tangent line. So that's the equation of the normal. And then you can plot the curve and the normal. And in fact, this curve is just a pair of straight lines, and that's why you have a constant slope for the curve. And the normal line, of course, is perpendicular to the curve, so that's the normal line. Okay, on to number 13, which says find the second derivative for this implicit equation. So if you find derivative, you get 2y into y prime minus 2x equals 0. Check the answer with D. Solve for the derivative, and you get back x over y, basically. Now work out the second derivative starting from the equation that you got early on over here, and you get back a simple result. You get back 2y times y double prime plus 2y prime squared minus 2 equals 0. Check with D. Solve for y double prime. And then you notice that you still have a y prime inside the answer. So you plug in y prime x equal to x over y, like I've done over here, and you get back the final result for y double prime. And finally, you go on to number 14, which says find the second derivative of this implicit equation. So you got sine of y equal to tangent of x. Work out the derivative on both the sides. Check the answer with D. You solve for y prime. Take a second derivative starting from the equation over here. So you get the expression over there. Check the answer with D again. Solve for y double prime. And then you still have a y prime x inside the result. So you plug in y prime x as secant x the whole square times secant y, and you get back the result for the second derivative. So this brings me to the end of today's problem session. I hope you've learned something about how to compute derivatives of all kinds. And we'll then go on to lesson 13, which is about rates of change. But before you do that, do make sure that you understand today's problem session quite well, and do practice a lot before we go on to the next topic. So thank you. I'll stop over here.